Hello and welcome to my video, lesson 6.1 on trigonometry or Sohcahtoa. So first thing to recognize is that Sohcahtoa needs a triangle and on top of that specifically a right angle triangle. And so what you want to notice here is a few different things. When you have wherever the angle is, that's what you're talking about when you say the words opposite or adjacent. So adjacent to the angle means next to the angle, and opposite means opposite the angle. Whereas hypotenuse is, as we said in the previous video, or sorry, not in the previous video, in when you talk about Pythagoras theorem, which is the longest side or the side that is opposite the 90 degrees. All right, so Sohcahtoa is useful when you have two sides and an angle. Okay, so you need two sides and one angle. Now you can be missing one of these and you can solve for the missing one. Okay, so all you need is one side and one angle, and you can solve for the other side, or two sides and you can solve for the angle. And that's because this is a 90 and you already do know the angle here. All right, so that's useful information because we're going to now look at the basic equations for Sohcahtoa. Now, it's just an acronym to help you remember the rules here. And these are the basic equations. So sine starts with an S. That's how you have an S there. Sine of the angle equals opposite over hypotenuse. Opposite over hypotenuse. All right, and the same format fits for each one of these now. Cos of the angle equals adjacent over hypotenuse. So C for cos, A for adjacent, H for hypotenuse. So it's following the same rule every single time. One more time here. Tan of the angle, let's just slide over a little bit, there you go. Tan of the angle equals opposite over adjacent. And I'm going to draw my arrows again. So T is for tan, opposite over adjacent. Okay, so that's nice. That tells us the basic equations. I'm going to actually add my brackets in because oftentimes and usually times it does have brackets. It does show the brackets. It always has brackets, but it either shows it or doesn't. Anyways, okay, so what we're going to do now is rearrange to solve for every one of the three answers. Based off of these general formulas. So let's first solve for the easiest one, which is to solve for O. So what we're doing now is we're pushing H to the other side. It was dividing, so now it's multiplying. And so that would be how we get O. The next question would be if we can use from this here equation, if we can divide out the sine theta, then we get that H is equal to opposite over or divided by the sine theta. Okay, and last but not least, we can do opposite operators to the sine function in order to get theta by itself and solve for theta. So what we do is we use this thing called inverse sine, which is sine to the -1 is how you write it, and it's opposite over adjacent. All right, so the point here is that each of these are just solving for a different value, but they're all based off the first one. So you should be able to rearrange the first one to get to any one of these. Now let's take a look at this next option. It's It's going to be the same thing, same format. I'm just going to move things around. So h gets multiplied to the other side. And so you're left with cos theta, h times cos theta. And then next option would be to have h by itself. And so we'd have a on top divided by cos theta. Again, they're all following the same format as the last one, including this cos to the negative 1. It's using the same format as before. So again, those three equations are very helpful, but they're all based off the first one. And now looking at the tan option, if we do the same thing and leave O on top and multiply 8 on both sides, on both sides, then we get A times tan theta. Our next option is A equals opposite over tan theta. And finally, theta equals tan to the negative 1, opposite over adjacent. So sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So those three equations are what you need for all the different options here for sine, cos, and tan, but they're all based off of this Sohcahtoa helpful acronym here. Okay, so with that in mind, which one are we going to be using for this triangle down below? So what we need to do is we need to recognize which of the two sides are we using and which one are we not using. Well, we are not using the opposite side. We're not using opposite. So which one does not have opposite? Okay, pause the video, try it out yourself, and then press play. Which one does not have opposite? Well, CAH does not have an O, does not have the opposite. Which means now we can look at this and say, okay, how do we solve for x? Well, we're going to write it in our regular equation, which is cosine of the angle equals adjacent, which is x, over hypotenuse, which is 15. And then you want to rearrange to get x by itself. So 15 needs to go onto the other side here. So 15 times cos of 30 degrees equals x. And if you type that into your calculator, 15 times cos 30 equals 12.99, or just 13. You can round it to 13. All right. Now let's take a look at this other option here, this next question. This is going to be the last one, so try it out yourself and then press play. All right, so what is the missing side here? Well, we are missing the hypotenuse, and we don't care about the hypotenuse. We're asking about the angle. So which one does not use the hypotenuse? Well, TOA does not use the hypotenuse. TOA does not use the hypotenuse. Okay, that's good. So now what we're going to do is write it in our regular format. Tan of the angle equals opposite over adjacent. Opposite is 3, adjacent is 4. And now we need to get the theta all by itself. So what we are going to do is do opposite operators, so opposite tan or inverse tan on both sides, which leaves us theta on one side and tan to the negative 1 of 3 divided by 4. I'm just plugging in my calculator as well. So theta equals 36.8, we'll just round it to 787, or you can just round it to 37 degrees. Alright, I hope this video helps you understand trigonometry and Sohcahtoa a little bit better. Good luck!